Okay, this is a continuation of our overview of confidence intervals and hypothesis tests. So let's just continue on. I believe we left off with topic number 8 that we're going to discuss. All right, the next topic I want to talk about is remember, a lot of times we try to find a sample size. We try to find n based on a margin of error. Okay, so in order to find a sample size based on a given margin of error, you have to be able to understand first that margin of error is like a within. It's like a plus or minus. I want to be within 5% for in terms of proportion, or maybe I want to be within 2 years. Maybe if I'm looking at the average number of years of life expectancy. So if you're working with margin of error is always equal to a z star or a t star if you're working with means times the standard error. So if you're working with means, your margin of error would be equal to actually, you probably would want to use T star, but if you don't even know your sample size yet, you're still going to use Z star. So maybe we want to be 95% confident, so we'd be using 1.96. And on the bottom here is the square root of your sample size, which you're looking for. And then somewhere up here, they would have to tell you the standard deviation. So maybe they tell you the population standard deviation is 0.45. So you'd have to solve this equation for n because they will also be giving you the margin of error. So make sure you know how to solve that. Now, if you're working with proportions, margin of error would be a percentage. Like I want to be within plus or minus 5%. And that's equal to, again, your z star, 1.96 for 95% confidence, times the square root of p hat q hat divided by n. But what do you use for p hat and q hat? The problem may tell you, or remember, if all else fails, use 0.5 and 0.5. But you got to use something there. And again, you're solving that equation for n. So make sure you can do that. We've done that in the past. Practice it, please. All right, moving on, not too far from being done here. Remember, once again, when you're working with intervals and difference of proportions, you do not have to pool. But when you're working with a test, difference of proportions, you do. So let's say that we have a sample of men, and we saw that, I don't know, 10 out of 50 men wear their seatbelt. That's 20%. And we saw a proportion of women, and maybe 20 out of 50 women wear their seatbelt, and that was 40%. Okay, so if we were doing an interval, okay, we would use the standard error formula where we're going to treat them separate. Men, zero point 0.2 times 0 0.8, sorry for my handwriting, divided by 50, plus women, 0 0.4 times 0 0.6, divided by 50. That would be the standard error formula for an interval. And you could calculate that. But if you're going to run a test, you need to pool. So we're going to do a giant square root as well, but we got to find p hat pooled real quick here. Okay, and that's going to be equal to the 30 total people that wear their seatbelts out of the 100 total people. So that would be 0.30 times 0.70 divided by 100. That's my mistake. Divided by the 50 men plus 0.30 times 0.70 divided by the 50 women. Okay, and again, p hat pooled, q hat pooled, all on top. Another way of looking at this formula is you could factor out that 0.3 and that 0.7 and take it out in front, not in front of the square root, but inside the square root still, and you'd have 1 out of 50 plus 1 out of 50. Okay, next one. Oh, keep going here. Okay, moving on. Let's talk about power real quick and the type 2 error and all that kind of stuff. Remember, this is, I believe, number 10. When we're dealing with alpha, alpha is not only your significance level, but alpha is also equal to the probability of type 1 error. Beta is equal to the probability of type 2 error. Now, these guys work in opposite. If I try to lower my alpha to like a 1% alpha level, I'm automatically going to be raising my chance of beta. Opposite of that would be if I increase my alpha, maybe to be less strict, I'm going to be decreasing my level of beta, type 2 error. Now, if the sample size stays the same, this is what happens. You try to move one down, the other goes up. You move one up, the other goes down. But remember, if you increase your sample size, you always will decrease both alpha and beta. Now, one is always still going to be more than the other, but increasing sample size will always decrease both types of error. Also, beta is directly related to power because power is equal to 1 minus beta. Now, you never have to calculate this because you never have to worry about calculating beta, but it's the idea that if I have a bigger sample, big sample, the more the sample, the better, I'm going to decrease both, and I'm also going to lower my or increase power with bigger sample size. Now the other thing I want to talk about, next thing I want to talk about p-value. Please be very specific with your p-value statement. If you have remember that your p-value is the probability of seeing what you saw or more extreme, comma, if the null is true. You got to make sure you have that in there. It's not the probability of the null hypothesis being true or false. It's the probability of seeing the statistic you saw given that the null is true. All right, and we're almost done here. Not too much more. Remember that I don't want to get p-value confused with stuff. So p is the true proportion of a population. P hat is the statistic or a sample's proportion. A p-value is the p here does not stand for proportion. It stands for the probability of, again, seeing what you saw or more extreme given the null is true. So let's just say that you want to run for election for mayor, or maybe I want to run for mayor. So I'm going to run a test. I'm going to run a sample and a test to figure out if I'm going to be elected. My null is that the true proportion would be 50%. 50-50, I may lose, I may win. The alternative is I'm hoping that the true proportion is greater than 50%. That means I'm going to win. So maybe my p-hat, my sample statistic, was 0.72. That sounds good to me. But I still need to do all that work to calculate my p-value. And let's say that my p-value ends up being 0.00001. That's awesome. That means with such a low p-value, I'm going to reject this null, take on the alternative, and I'm going to be very confident with such a low p-value that I am going to win the election. So again, this p-value tells me that seeing what I saw is extremely unusual if the null is true, which tells me that I'm pretty confident I'm going to win. All right, let's see here if we have one more. Okay, last thing I want to talk about here, getting down the nitty-gritty here. Please make sure that you understand that if you are running a test for proportions versus an interval of proportion, you use slightly different values. If somebody tells us, I believe this is maybe number 12 or 13, I can't remember. If somebody tells you that we saw a sample, and in a sample we saw, I don't know, 52% of people that wear a seatbelt. I seem to be using that seatbelt example a lot here. Now, maybe we thought beforehand, that the true proportion, maybe somebody told us or we thought, was only 50%. Okay? An alternative would be that, hey, we think that a new campaign to wear your seatbelts, click it or ticket is going to raise that above 50%. So, if we're going to actually calculate that z-score, we start off with what we saw, 0.52 minus we were supposed to see, 50%, divided by a standard error. Now, the standard error that's going to go here is based on the truth we are assuming, not the sample. So the standard error that would go here would be 0.5 times 0.5 divided by sample size of 100, whatever say it was. Now notice that if this was an interval, if we were trying to interval, if we didn't know the truth at all, we were trying to if we were trying to find an interval to calculate the truth, we'd be using 0.52 and 0.48. But in a z-test, to actually try to calculate a test for this z-score, we want to use what we're thinking the truth is. Okay? So to be honest, guys, if you don't study, if you don't take a look at these two videos, it's going to be like using a broken pencil. Pretty pointless. So there's going to be 18 questions on the test. I just went through 12 major concepts. Probably will help you with 12 questions. Hopefully the other ones will also help you. Hopefully, based on using all your knowledge, you'll be able to answer the remaining questions. I think you guys will do great if you please watch these videos.